Hello. Good morning to everyone. Welcome to Gate Academy 2.0. This is Satish Kumar Durishetty, Faculty of Instrumentation and Measurements. How are you all? Is my voice and audio video everything is clear? Before starting the session, is audio video everything is clear? Good morning Manish, good morning. Rohit Gaikwad, good morning. Tech Mathurji, good morning. Good morning everyone. Good morning everyone. Good morning everyone. Yes, सब कुछ ठीक है ना? Yes, yes, yes. So my dear students, by yesterday we have completed the bridges topic. Okay, so we are discussing electrical measurements. Okay, under the electrical measurements every day we are taking some topic and respective problems also we have done. So under the bridges we have discussed the DC bridge and AC bridge. Under the AC bridges we have covered all the bridges: Maxwell inductance bridge, Maxwell inductance capacitance bridge, Hayes bridge, Anderson bridge, Owens bridge, sharing bridge, D.Sathish bridge, Wien's bridge. Okay, so all these bridges we have done. So today, interestingly, I want to talk something about non-electrical measurements. I want to talk about some non-electrical measurements, especially the students. Many students were asking, sir, please take 1 or 2 sessions on transducers. So I told them in the middle of the electrical measurements, I will be taking 1 or 2 sessions. Why? Because in the exams like state level electricity board papers, and some people are writing some RVUBNL exam, Rajasthan Electricity Board, Rajasthan Vidyut Vitaran Nigam Limited, and in the south states also like Tamil Nadu and South India states like the Andhra Pradesh and Telangana also some notifications are expected, GENCO notifications are expected. So for all those notifications, my measurements classes will be more than sufficient actually, but the thing is you have to practice. You have to practice from a booklet, many number of questions you have to practice. Okay, so yeah, so that's why we are taking some non-electrical measurements also. Today I will be discussing some non-electrical measurements. So what are the non-electrical measurements important for the power plant? Non-electrical measurements, just 1 or 2 sessions. So 2 sessions I will discuss. Today's and next one more session I will discuss. 2 sessions I will discuss for non-electrical measurements in brief. Okay, all of you are comfortable? Manish Kumar, are you comfortable? Rohit Gaikwad, are you comfortable? Everybody is comfortable. Those who are preparing for this session is for non-electrical measurements. Okay, so this session for non-electrical measurements. Why? Because I want to get some I have got some messages from the dear students. Sir, we are preparing for state level electricity board papers. In the state level electricity board papers also sometimes the questions are asked. See, for example, if you see the thermal power plant, my dear student, so if you see the thermal power plant, in the thermal power plant what is happening? In the thermal power plant what is happening? So first there will be a coal. The coal gets heated, that means there is a temperature. Then comes the water. Water is coming from the river. When the water is coming from the river, there is one parameter called flow. So this temperature is going to touch to the flow, then steam is going to be generated. That steam is having certain pressure and velocity. So this pressure and velocity is going to hit the turbine. So when it hits the turbine is going to rotate. When the turbine rotates, there is an angular velocity and the speed of rotation omega n. Then comes directly your electrical power. Am I right or not? Power is equal to torque into omega. So where this omega is equal to 2 pi n by 60. So once the electrical power comes, there comes your voltage, there comes your current, there comes your resistance, there comes your inductance, there comes your capacitance, there comes your magnetic flux, there comes your admittance, there comes your resistivity, there comes your power factor, there comes your reactive power, there comes your active power, and all these things we are going to get or not. Do you understand, my dear students? So in the real time, Sir, transducers is in GATE in EEE syllabus. No, it is not there in the GATE EEE syllabus. It is in non-GATE. Okay, like IES, GENCO, state electricity boards. Okay, na? Just, is it clear, my dear student? Okay, so if you see the power, the basic electrical power is coming from non-electrical parameters like temperature, flow, pressure, velocity, angular velocity, speed of rotation. So these all are what? These all are what? Non-electrical parameters are not? Temperature, flow, pressure, velocity, omega, n. Am I right or not? Torque. So this is the temperature, flow, pressure, velocity, omega, n, torque. These all are what? Non-electrical parameters na? These are your non-electrical parameters or not, dear students? Hello sir, Ananja Bose, good morning. So these are non-electrical parameters. Next, if you take the solar power plant, in the solar power plant, what is happening? The sun will be there. So from the sun, sunlight is coming. So this light is going to hit the plates. So from the sun, it is going to hit the solar plates. So this is what we call as solar cell. So from the solar cell, we are getting the voltage. Okay, my dear students, that means what here, what is happening? The light is converted to electricity. All of you understanding? Next, in hydro power plant, what is happening? In hydro power plant, what is happening? The river water is coming. So there is a water flow rate. This is stored in a reservoirs. So there are certain reservoirs are constructed. So the reservoir high potential energy is converted NGZ. So this potential energy is going to convert it into high kinetic energy. This kinetic energy is nothing but half mv square, and that is going to hit the turbines, and the turbines are going to rotate. Then comes the power is equal to torque into omega. So if you observe all these things, there are so many non-electrical parameters. So this is a non-electrical parameter, this is a non-electrical parameter, this is a non-electrical parameter, these are non-electrical parameters. So there are certain instruments, you should have some idea. The instruments are called transducers. The transducer is a device. Basic idea you should have. I think Ananja Bose, your instrumentation student, you are having some good knowledge on the subject transducer. But for electrical students, this knowledge is not there. Yes or not? Ananja Kumar, Shubham Mathur, Manish Kumar, Rohit Gaikwad, all of you are following my session. So what is this transducer? This transducer will convert non-electrical quantity into electrical quantity. This transducer is converting non-electrical quantity into electrical quantity. So non-electrical quantities means like temperature, pressure, flow, light, displacement, velocity, acceleration, torque, okay na, light, you can say the flow rate and the sound and the humidity. So all these parameters are converted to electrical parameters. All of you are following? Interesting na? Alok Kumar, Rohit Gaikwad. Hi Rohit Gaikwad, are you? Yes, non-electrical to equivalent electrical. Very good. So this particular subjects, why? Because when you are writing the competitive exams, in the syllabus, if it is mentioned, then definitely there is a possibility of expecting a question. So that's why two sessions I am dedicating for transducers. Today's session and tomorrow's session I am completely dedicating for transducers. Those who are preparing for state level electricity boards. Okay now, so that topics I am going to discuss. So if you see this non-electrical to electrical, so we are having resistance, temperature, pressure. These are the the basic definition, which converts non-electrical to electrical. So there are actually for electrical students, there are list of transducers are there, a big list of transducers are there. Just have a basic idea. So what is the first one? I am going for resistive transducer. So what is a resistive transducer? Listen carefully. So I am taking for resistive transducer. So what is mean by resistive transducer? So resistive transducer means what? Resistive transducer. Resistive transducer means what? Resistive transducer means in a process of conversion of non-electrical to electrical, in a process of conversion of non-electrical to electrical, in a process of conversion of non-electrical to electrical, if resistance is the principle involved, if resistance is the principle involved, then that is called resistive transducer. Is it clear? Similarly, in a process of non-electrical to electrical, if inductance is the principle involved, that is called inductive transducer. In a process of non-electrical to electrical, if capacitance is involved, then that is called capacitive transducer. So there is a big list of resistive transducers. So the big list of resistive transducers. Just today's session, I am giving the complete information overview of all the topics. Resistive transducers list. So there are certain resistive transducers. For example, if you come to the first one, so first one is potentiometer. This potentiometer is useful for what measurement? It is useful for displacement measurement. Potentiometer, when you are applying the displacement is going to be converted to the voltage by changing its resistance. So for example, let me take one example here. So this is our potentiometer supply voltage. So this is our potentiometer resistance. Okay, so this is our potentiometer resistance. So if you see now, this is a slider. The slider is movable. So we are going to take the output voltage across these terminals. So this displacement we are applying is Xi. So this displacement is the total displacement Xt. So this is our Ei. So we are going to measure the output voltage. As this displacement is changing, this output voltage is going to be changed. That's why potentiometer converts displacement into voltage. Potentiometer, what is happening? For potentiometer, I am applying input displacement and output is voltage. So in a process of conversion of displacement to voltage, its resistance is involved. Is it clear, my dear students? All of you are following? Please show me your thumbs. Ananja Bose, Mathurji. Other students, Manish, Gaikwad. So displacement is converted to voltage. In a process of conversion of displacement to voltage, the resistance principle is involved. And the second example is strain gauge. So basic idea you should have. So what is strain gauge? This particular strain gauge will change its a force, its a stress, its a pressure, it's a strain, even the displacement also into the voltage. The best thing I can explain you, when you go to the kirana shop, you can observe grocery shops. When you go to the grocery shop, so there is a surface like this. Am I right or not? All of you are following? So when you go to the grocery shop, there is a surface like this. So now on this surface, so this is a surface like this. So on this particular surface, adjacent, there is a vertical column you can watch. There is a vertical column you can watch. There is a vertical column you can watch. On this vertical column, the merchant is going to keep the weight. So here comes the weight of a body. Then you can watch the digital display here. we can watch the digital display here. Do you understand? So strain gauge is converting the stress or the weight into the digital display. So what is happening here? What is happening here? The weight is converted to digital. That means the weight is first converted to electrical inside, then it is converted to digital. Am I right or not? So what is the strain gauge is doing? Strain gauge is a resistive transducer present inside this particular surface. So this particular surface, whenever it is under stress, its weight is converted to digital. So this is what we call strain gauge. Clear all of you? Yes, Anand Bose, clear? Tech Mathurji. It is our electronic weighing machine. So strain gauge is converting the non-electrical quantity into electrical. So electrical students should have basic idea of this. So next comes temperature devices like RTD. RTD means it is related to temperature measurement. Next, fourth one, we are going to get thermistor. So thermistor is also temperature oriented. Excuse me. This RTD is made by metals. So RTD is made by metals. The metals will have positive TCR. The metals will have positive temperature coefficient of resistance. So as you are aware of this, as the temperature is increasing, the resistance also increases. As the temperature is increasing, resistance also increases. So this is the way how the graph will be there. But for semiconductors, if you see, what is going to happen? As the temperature is increasing, resistance is going to decrease exponentially. As the temperature is increasing, resistance is going to decrease exponentially. Clear, my dear students? So this is our RTD thermistor. Next comes LDR. So LDR stands for light dependent resistor. What is this? Light dependent resistor. So what is happening here, my dear student? So as the light intensity is increasing, its resistance is going to be decreased. So this is our light intensity. So as the light intensity is increasing, its resistance is going to decrease exponentially. So this much basic knowledge you should have. Thermistor for semiconductor, yes. Thermistor is for semiconductor. Here I am right. So thermistors can be prepared with semiconductor. I have written already, Mathurji. Thermistors are having negative temperature coefficient of resistance. They are having negative temperature coefficient of resistance. As the temperature increases, resistance decreases exponentially. And LDR is called light dependent resistors. So these are also called as photoresistors. So these photoresistors will change. As the light intensity is changing, the resistance is going to be changed exponentially. So these are also called as a light intensity, as the intensity of light is increasing. As the intensity of light is increasing, the resistance is going to be decreased. That means the current passing through the LDR is also going to be increased. That means because of the photons, the conductivity is increasing. So that's why this is what also called as photoconductive cell. What we call it as? Photoconductive cell. So this is also called as photoconductive cell. So this much knowledge is enough when you are facing some memory based questions, especially some memory based questions are asked. So this is our LDR. Next most important thing is, so Pirani gauge. What is this Pirani gauge? This Pirani gauge is suitable for measurement of low pressure of a gas. Okay. So next comes hot wire anemometer. You should have all this idea of instruments. Hot wire anemometer. So you can remember this. Anemo means Pavan. Anemo means you can remember like this, Hanuman. Anemo means you can remember like this, Hanuman. Hanuman means you can remember like Pavanaputra. Anand Bose, are you there? Pavan means what? Pavan means air. So anemometers are suitable for flow rate of air measurement. flow rate of air measurement. So this is the most important thing you have to understand. Why? Because some of the measurements are important with respect to non-electrical also, flow rate of air. So flow rate of air or gases. Flow rate of air or gases. Do you understand, my dear students? So these are the basic resistive transducers list. So just for idea, I have collected all the information. So please, you try to practice this list. You try to remember this list. So first comes the potentiometer, next comes the strain gauge, next comes the RTD, next comes the thermistor, next comes the LDR, next comes the Pirani gauge, next comes the hardware anemometer. All of you clear up to this, my dear student? Solar cell is not LDR, no. Solar cell is different, LDR is different. Solar cell is different, LDR is different. LDR is different. Okay, do you understand, my dear students? So these are the points. For LDR we use semiconductor material, not PN junction like photodiode. Yes. Clear all of you? These are some memory based questions. Sometimes theory questions are asked. The students are missing these concepts, so they will fail. They will unable to answer this. That's why today I am discussing these informative oriented questions. All of you clear up to this? All of you noting down all this information? All of you noting down this information? So what is RTD, what is thermistor, what is LDR, what is Pirani gauge, what is hardware anemometer, strain gauge, potentiometer? All of you are noting down this information? Is it clear? Yes. Pirani gauge for vacuum pressure measurement, right? Yes, low pressure means vacuum. Low pressure means it is called vacuum. Low pressure measurement is called is nothing but vacuum. Low pressure measurement is also called as vacuum. Okay, so these are some instruments. You should have idea of all these instruments. Why? Because sometimes match the followings also can be expected. Okay, so next comes capacitive transducers. So if you see the capacitive transducers list, so what is capacitive transducer? Capacitive transducer. In a process of non-electrical to electrical, what is happening? In a process of non-electrical to electrical, if capacitance principle is involved, that is called capacitive transducer. The best example, if you see the capacitance, C is equal to epsilon A by D, am I right? C is equal to epsilon A by D. So this C is proportional to overlapping area. So this C is proportional to inversely proportional to distance between the plates. This C is proportional to permittivity. That means what? If you see now, if these are the two capacitor plates, and the gap between these plates is D, and the overlapping area is A, and the dielectric medium is air. Okay, so what is happening now? Whenever you are applying some displacement to it, suppose if you are applying the displacement to it, then what happens? If the displacement is applied to one of the plates, then the overlapping area is going to be disturbed. Or if you apply the pressure signal to this, the gap between the plate is going to be disturbed. You understand? So same types of Wheatstone bit circuitry is used for Pirani gauge and hardware. Yes. Signal conditioning is same. Clear? So capacitance is changing due to overlapping area, capacitance is changing due to distance between the plates, and capacitance is changing due to permittivity. Okay, so by applying the non-electrical quantity, so if you observe this C is proportional to area, this area can be variable as a function of non-electrical quantity. C is inversely proportional to D, this D can be variable as a function of non-electrical quantity. C is proportional to overlapping dielectric permittivity, so that also variable as a function of non-electrical, f of x. So if you are changing the C as a function of area and the area is changing as a function of displacement, then this is called as variable area, this is called as variable distance. So 3 transducers. So the first one is a variable area capacitive transducer. Variable area capacitive transducer. So this one is called variable distance capacitive transducer. Next, this one is called variable permittivity capacitive transducer. All of you understood? So variable area type, variable distance type, variable permittivity type. Variable area type, variable distance type, and variable permittivity type. All of you clear about this? All of you clear about this? So 3 types of transducers. Good morning, Tirumalai. So good morning. So variable area type, variable distance type, variable permittivity type. The best example, if you see the microphone. If you see the microphone is a capacitive transducer. The best one I am saying, the microphone. So if you see this microphone, what is happening on the microphone? So for the microphone, so these are the capacitor plates. On these capacitor plates, there is suppose a certain layer called diaphragm. So this is the diaphragm. So this is what we call as diaphragm. So on this diaphragm, we are applying the sound signal. When you are applying the sound signal, the sound wave comes like this. The sound wave comes like this. Then it pushes down and gives a pressure, and this pressure makes this capacitor plate to come down. So when it comes down, the gap actually was D. This gap was D and this displacement was X. So the new gap will be what? D minus X. The new gap will be what? D minus X. So now if you are placing this particular capacitor, as a part of an analog circuit, so here comes our supply. So this is a supply. So this is a variable capacitor ho gaya. So this is our transducer and this is our resistance RF and this is an inverting op amp. Now do you understand what is happening in this circuit? Do you understand what is happening in this circuit, my dear student? It's a beautiful topic. So this is how the microphone looks like. Hi Himanshu Bharati, good morning Sirji, good morning. Yeah, good morning, good morning. Tirumalai, vanakkam, kaise ho? Tirumalai, how are you, man? Your lectures is so good. Thank you, Tirumalai. Thank you. Welcome. Thank you very much. Thank you very much. Thank you very much. Please try to post a review. Try to post your constructive comments in the Telegram channel so that everybody can understand the sessions. Okay? Mathurji, it is not piezoelectric crystal. I am talking about capacitive transducer. So whenever the sound signal is applied to a diaphragm, the diaphragm makes these capacitor plates to come down, the gap changes and the transduction takes place and the V0 is going to come into picture. So when I am talking, the sound wave is touching this particular, so you can see this mic here, all of you are able to see this mic. When I am talking, the sound is touching this diaphragm. Beneath the diaphragm there is a capacitor plate arrangement. That capacitor plate arrangement is going to be disturbed because of the pressure. The capacitance is going to be changed. And we are going to get the output voltage by using the signal conditioning circuitry. All of you are clear about these points? We are having a signal conditioning circuitry. So this is a signal conditioning circuitry, you can see. So this is a signal conditioning circuitry, this is an op amp. So like that it is going to convert into voltage. So microphone, what is happening here, if you observe, the microphone is converting, try to understand my dear students clearly. So the microphone is converting sound to voltage. So this is our microphone. So this microphone is converting sound to voltage. So whereas the loudspeaker is converting There is one more device called loudspeaker. This loudspeaker is converting electrical voltage. This is the electrical voltage to sound. Yes, but it has many other applications. Piezoelectric crystal also will do, but it has many other applications. Yes, it is more than enough. These lectures are more than enough. Why? Because in IES prelims, questions are asked on transducers also. More than enough means you have to practice. Practice bits also, then only it is enough. Tech Mathurji, piezoelectric crystal is also used. Piezoelectric crystal also used for the same application, for the same app, but it is a active transducer. Okay na? So if you see now, the sound is converted to voltage. So sound is given to microphone is converting that into voltage. So this is called as transducer. Why? Because here a non-electrical quantity called sound is converted to electrical quantity called voltage. Whereas a loudspeaker, if you check, the loudspeaker is converting electrical quantity into non-electrical quantity. So that's why the loudspeaker is called as reverse transducer. Reverse transducer we call it as. Other name for the reverse transducer is actuator. Other name for the reverse transducer is what? Actuator. So these are the words. Yes, capacitive or passive. Yes, capacitives are passive transducers. All of you clear about this, my dear student? So what is active and passive? That also an important point. In exams it is asked. Passive transducer means what? Non-electrical quantity is converted to electrical quantity. In a process of conversion of non-electrical quantity to electrical quantity, if there is a external supply voltage is utilized, okay, in a process of conversion of, why the extra AC supply is fed to the input of op amp? It's a capacitive transducer. Ananja Bose, it is a capacitive transducer. We can use the DC supply also. My dear student, it is a capacitive transducer. You need some supply. Here you can use AC or DC also you can use. AC or DC you can use it, man. If there is no supply, then how the charge can change? Basic charge is required, my dear student. The Q is equal to CV. If V is not there, there is no charge. The change of charge with respect to time, that is called current. So first, to generate the minimum charge, we require the voltage. When you apply the pressure, then the capacitance changes, then automatically the charge changes. So Q is equal to CV concept, Ananja Bose. If you are expecting the current to this circuit, dq by dt should happen. dq by dt should happen means either the capacitance should change or the voltage should change. Then only there is a current possibility, my dear student. Is it clear? My dear student? Ananja Bose, instrumentation ka bachcha. So if you are expecting the current, either this should be possible or this should be possible. That's why I am using some excitation. Clear na? So if you are using a passive transducer in a process of conversion of non-electrical to electrical, if external supply voltage is used, it is called passive transducer. So the example for passive transducer, can I say all RLC transducers are passive transducers? Tirumalai, Ananja Bose, all RLC transducers are passive transducers. Resistive, inductive, capacitive transducer, all are passive transducers. Why? Because a resistor requires some external supply voltage, a inductor requires some external supply voltage, a capacitor requires some external supply voltage. There is one more device called active transducer. So what is active transducer? So if you see the active transducer, for active transducer, in a process of conversion of non-electrical to electrical, in a process of conversion of non-electrical to electrical, no external supply voltage, no external supply voltage, no external supply voltage, then it is called as active transducers. Examples, active examples are piezoelectric crystal. What is this? Piezoelectric crystal and thermocouple, solar cell. Solar cell is also called as photovoltaic cell, and pH electrode. So these all are list of active transducers. So piezoelectric crystal, thermocouple, solar cell, pH electrode. Yes. All of you clear, my dear students? No, it's not like that. Active is also used for energy conversion, but the point here is whatever the energy is required to convert to non-electrical to electrical, that energy is demanded from outside, then it is called passive. Whatever the energy required for conversion of non-electrical to electrical, it is rebuilt within itself, not depending upon the external. जो कुछ एनर्जी चाहिए नॉन इलेक्ट्रिकल टू इलेक्ट्रिकल कन्वर्शन करने के लिए, जो कुछ एनर्जी चाहिए वो एनर्जी खुद से बन रहा है, वो ट्रांसड्यूसर को हम बोलते हैं एक्टिव ट्रांसड्यूसर. वो बाहर से निकाल रहे, बाहर से ले रहे एनर्जी को, देन उसको हम पैसिव बोलते हैं. ओके ना? Actuator is a final control element like control valve etc. Can we call inverse trans? Yes. Actuator converts any form of energy into mechanical motion. So it is a reverse transducer only. Is it clear, my dear student? Actuator converts any form of energy into mechanical motion. Actuators, some are hydraulic actuators, some are pneumatic actuators, some are electric actuators. Okay na? Hydraulic actuators, pneumatic actuators, electric actuators. Hydraulic actuators will convert hydraulic form of energy into motion. Electric actuators will convert electric into motion. समझ में आपको? Pneumatic actuators will convert pressure into motion. मजा आ रहा है? So this is a theoretical topic. You should note all these things. Clear है? माथुर जी clear? आरंज बोस clear? तिरुमलाई clear? Everybody is clear? Please show me your response here. Your response matters to us. Why? Because जो कुछ content मैं दे रहा हूँ, whatever the content I am giving, this content is the best content. Why? Because when you are writing the competitive exams like GENCO, AP GENCO, Telangana State GENCO, Rajasthan GENCO, SSC JE, in such exams, some theoretical bits are asked. I think Tech Mathurji, you know, you can share your experience. You are writing the regular exams. You are writing the regular exams, right? Yes or not? You are writing SSC JE, you are writing, yesterday you messaged me, sir, I have written some exam. In that exam, the watt meter question asked, sir. The power measurement question asked, sir. So you can post your comment, Mathurji, over there. What was your experience of measurements? Why? Because syllabus overview you have to cover. Why? Because having only expertism only in one area is not sufficient for the competitive exam. Ananja Bose, that's what I am telling. Having only one area as expertism not sufficient. Why? Because for competitive exams, you should be in a position to cover all the topics. Then only you can secure the rank. See what happened last year in a GATE exam. The only one question came on the measurements. Which of the following bridges is suitable for inductance measurement? Suppose if a student is making so much of attention for power measurement, energy measurement, and all other basic instruments like PMMC, moving around, he solved many problems, but he has not covered the bridges topic, then the question will come on the bridges topic. That's why I am telling. What questions are asked, Mathurji? You can post there. What questions were asked? In your interview, what are the questions asked? That will be benefit for all the students also. That will be benefit for all the students also. Can you post what are the questions asked in particular interview? Tech Mathurji, what are the questions asked? Ananja Bose, your doubt is clear about actuator? Ananja Bose, your doubt? Yes. Yes, sir. Yesterday, CERI interview was there. So errors in wattmeter, ammeter, voltmeter, PMMC, MI question, and also one question, what happens when a spring in PMMC snaps? Yeah, I explained you. If one spring is snapped, what happens? If two springs are damaged, what happens? I explained you. If one spring is snapping, that one spring is in series with the other spring also, then definitely what happens? The controlling torque is not going to be there. Only the deflection torque will be there. Am I right or not? So one spring is damaged, then snaps away. What happens? The controlling torque will be more, deflection torque will be more than the controlling torque. That's why the pointer will go to the maximum point and then again it will come back. If the two springs are damaged, then there is no current passing. Yes. All these things we have discussed. Yes. That's why the fundamentals, wherever I am discussing, with respect to competitive exam, the subject preparation is different. Mathurji and Ananja Bose, Tech Tirumala I am telling. Having expertise in subject is different. Feeling the subject and preparing the subject for a competitive exam is different. When you are going for a competitive exam, what type of questions are asked? That is also important. What areas they are covering? That is also important. What happens? The students will prepare their favorite topics for 80% and they will leave certain topics like the sensors, transducers, measurements, bridges. The topics they will leave. When you go to the exam, in the exam they will ask such type of simple questions. Simple questions. All of you clear about here, my dear students? Passive and active transducers, very clear na? Chalo. Now we'll go for inductive transducers. What is inductive transducers? Just I am giving the list of inductive transducers. In brief I am discussing. So inductive transducer, what is inductive transducer? Inductive transducer means in a process of conversion of non-electrical to electrical, in a process of conversion of non-electrical to electrical, if inductance principle is involved, then it is called inductive transducer. So when I say inductance, my dear student, it can be self-inductance or it can be mutual inductance also. So there are two types of inductances. One is a self-inductance, other one is a mutual inductance. So what is self-inductance? What is mutual inductance? So if two coils are present, so if this is our self-inductance. Self-inductance is a property of a single coil. So whenever a current travels around this particular thing, some magnetic flux is going to be generated. So now if you are bringing a box of iron made, suppose if you take an iron, so this is a ferrous. So if you are pushing this ferrous nearest to this coil, if you are applying the displacement nearest to this coil, then there is a change in flux. If displacement is increasing towards this side, then the air gap jo kuch hai, that air gap is going to be decreased. Agar air gap decreases, then what happens? The reluctance decreases. When the reluctance decreases, what happens? This is iron rod, so this is highly permeable, so it is having good permeability. So when reluctance decreases, it attracts the more flux, the flux component increases. Am I right or not? When the flux component increases, the self-inductance increases. So why? Because we know very well L is equal to n number of flux lines per unit current travel. So as a current is increasing, my dear student, as a displacement is increasing, my dear student, the self-inductance also increasing. A non-electrical displacement is converted to electrical inductance. That's why it is called we call it as proximity. What we call it as? Variable reluctance displacement transducer. It is also called as inductive proximity. What we call it as? We call it as inductive proximity. Do you understand? So proximity is other name for a transducer we can use. It is called as inductive proximity. All of you understanding, my dear students? Is it clear? Maza aa raha hai? Why? Because these are some information questions. Okay na? Chalo. Next comes mutual inductance. Mutual inductance is a Tirumala, are you there? Are you following? Mutual inductance is a property of not one coil, it is a property of two coils. So there will be two coils like this. So for the two coils, so now if you apply in two coils, there is mutual inductance phenomenon. So when a current passes here, that current can create a flux in here also because of the mutual inductance component. So now what I am doing, in between these particular coils, if I keep a core, and if I keep a core to this ferrous, and this ferrous, if I am applying the displacement, then what happens? This displacement can change the voltage across these particular devices. So this concept I will use in one device called LVDT. So what is LVDT? So if you take the LVDT, so this is our primary winding. So this is our primary winding, and there are two secondary windings, my dear students. So two secondary windings I am taking like this. So in these two secondary windings, so these two windings are crossed, and here comes our output voltage. So this output voltage I am going to measure. So this output voltage is going to be changed as a function of displacement. So if you are applying some displacement to it, so this ferrous core, if it is moving forward, then here the magnetic flux will be more, here the voltage will be more. Suppose if it is moving down, then here the magnetic flux will be more, and here the voltage will be more. So that is, as a resultant, what is happening? As a resultant, we are getting the E differential. So E differential is equal to what? ES1 minus ES2. That means the displacement applied is converted to the voltage. If it is magnetic flux associated here and the magnetic flux associated here will be same, if it is exactly at the center, this differential flux will be 0, output will be 0. That means what? If you are applying the X, and if you are taking the E differential ES1, and if you are taking the ES2, and if you are taking the E differential, what is happening? If displacement is equal to 0, the ES1 and ES2 both are equal, then E differential will be 0. All of you are following, my dear students? If displacement is moving in the forward direction, if X is positively increasing, it is moving upward, then the ES1 will be more than ES2, then E differential will be positive. If displacement is happening in the negative direction, if it is moving in the negative direction, then ES1 will be lesser than the ES2 and E differential will be negative. All of you understood? So it is going to be negative, my dear students. So this makes the LVDT arrangement. So what we call this as? We call this as, Ananja Bose, can you full form? Ananja Bose, can you elaborate this? Ananja Bose, instrumentation student, can you elaborate this LVDT? What is LVDT? LVDT stands for linear variable differential transformer. Linear variable differential transformer. Okay now? So this is an expected question. It is what we call as clear? All of you clear, my dear students? Perfect ना? Everything is clear? ऑडियो वीडियो क्लियर भाई? एक बार बताइए, थोड़ा सा डिस्टर्बेंस आ रहा है इधर. Audio, video, everything clear? Yes, for LVDT, supply frequency is 10 times the core displacement frequency. Yes, the frequency of excitation, the frequency of displacement matters. We are applying the linear displacement. Linear displacement. It is a linear displacement. Differential means output is differential. Why it is called transformer? Transformer means, if you observe, sometimes you are getting the step up, and sometimes you are getting the step down. Clear, Tirumalai, LVDT, if you see the LVDT, if you are applying the linear displacement Xi, then it is called linear variable differential transformer. Suppose if you are applying the angular displacement, there is another name called RVDT. So RVDT, for this we are applying angular displacement. It is called, we call rotary variable differential transformer. Is it clear, my dear students? Rotary क्या क्वेश्चंस पूछ रहे हैं तिरुमला भाई? रोटरी बोल रहे हैं, मैंने बोल दिया आपको रोटरी बोल के, नॉन लीनियर बोलते रोटरी बोलते हैं, उसमें क्या फर्क पड़ेगा? If it is not linear, it is angular. If it is not linear, it is angular, then it is called as RVDT, rotary variable differential transformer. Then the construction is different, beta. The construction is going to be modified. Is there any problem due to harmonious of supply signal in LVDT? Yes, the harmonious can affect the LVDT output. If hormones are there, harmonics are happening in the LVDT supply, then definitely that is going to apply the E differential may, you are going to get the signal like this. Ananja boss, is it clear? So you are going to get the signal like this. So this is output signal is going to be, and this output signal is again has to be by using some communication subjects. We have to make this as given to signal conditioning. We have to give this to a signal conditioning model. So again you have to process the E differential just like the displacement. I have to get the E differential like this. As a displacement is increasing, the output voltage should increase. As a displacement is decreasing, output voltage should decrease. So if harmonics are present, the signal is going to be like this. By using the signal conditioning, you have to make like this. Signal conditioning circuitry. Hi Sharma ji, good morning. How are you, man? Abhi kaisa ho? Are you in journey today also? Chinoy Sharma ji, are you in journey today also? Yes. How can we eliminate that odd harmonic? Signal conditioning. Signal conditioning. Signal conditioning circuit like demodulator, filters, you can add to LVDT. Clear? Ananja boss, clear? Signal conditioning circuits like demodulators, filters, you can add it to LVDT, then so that it can be smoothly modified like this. समझ में आपको? So this is all about, yes, low pass filter. Yes, low pass filter. Very good. We have to use a low pass filter. The low pass filter will eliminate the high frequency harmonics. Perfect, perfect. Does harmonic can create noise? Harmonic can create distortion. Harmonic can create distortion. Harmonic can create distortion. Harmonic can create distortion in output. Sure. So that is about LVDT. So we have seen RLC transducers. Clear all of you? Clear all of you? So such type of questions, such type of theoretical questions. Now let me explain you some optical transducers. So if you go for active transducers, if you go for optical transducers list is also important. So if you go for optical transducers, the first one is the LDR. This LDR is what? Light dependent resistor. Light dependent resistor. There are certain materials. There are certain materials like cadmium sulfide, cadmium selenide, lead sulfide, lead telluride. So these, if you observe, these are the combination of semiconductors. These are the combination of semiconductors. So basic functionality of semiconductor material everybody knows. In semiconductors we are having one concept called energy gap. So this is our E1, this is our E2, and the energy gap is nothing but E2 minus E1. So electrons are waiting for the energy here. So they require some energy. So the energy required is, suppose if a light is focused from a light source, if a light is focused like this, if a light is focused like this, so this light is focused, we know very well light is having energy. The energy of the photon we know very well, h in nu, h into frequency. Sharma following, Aranja Bose following, h is c by lambda, frequency is equal to c by lambda. Shorter the wavelength, higher the energy of the photon. Longer the wavelength, lesser the energy of the photon. This is EDC subject. So if energy of the photon is greater than energy gap, if energy of the photon is greater than energy gap, then what happens? Taking that energy, this electron will jump to the higher energy levels. Electron is jumping to the higher energy level means photons hitting, electrons jumping. So this is the electron jumped here and here the hole formed. That means they are moving from the valence band to conduction band. So what happens? If energy of the photon is greater than energy gap, then the photons will enter, photons are hitting, then the electrons are moving. The movement of electrons is called current. So this is what we call conductivity. So as the photons are increasing, the conductivity is also increasing. So this particular phenomenon is called photoconductive effect. Photoconductive effect, and the device which is working on this principle is called photoconductive cell. So now what I am doing, LDR is basically a resistor. LDR is basically a resistor. If you see the op amp circuit, so this is our EI, supply voltage, and here I am keeping the LDR. If I am keeping the LDR here, so this is a light dependent resistor. So whenever the light is focusing here, when the light focus here, its resistance is going to be decreased and the current is going to be increased. So if this current is connected to a op amp network like this, and here comes another resistor, my dear student, and here comes the voltage V0. So this is a feedback resistor RF. So now what I can write, so this particular phenomenon, this is the inverting op amp. So V0 is equal to minus RF by R1 into V in. So what is minus RF? That is RF. R1 is the resistance of the LDR into V in. So if you check the closed loop gain beta, the closed loop gain beta is equal to RF by RLDR. As the light intensity is increasing, resistance of the LDR is decreasing, then the beta increases. That means the gain increases. That means the V0 is increasing. It is used in circuits as a AGC circuit. What is AGC? Can anybody tell me? What is AGC? Can anybody tell me? Yes, Ananja Bose, क्या पूछ रहे आप? Crystal clear. Is doping required for these type of materials to fabricate LDR, or it's simply no. Doping is required. Doping is always required. As certain impurity concentration only can respond for certain lambda of light. समझ में आपको? Ananja Bose, your doubt I answered. Everything matters. Yes, AGC stands for automatic gain control. My dear students, matter matters. So this is the sun, this is the lambda, and this is the matter. Always remember, my dear student, always remember, the matter matters. पदार्थ में जो कुछ है ना, वो पदार्थ, द पदार्थ जो कुछ है ना, द मैटर जो कुछ है ना, material matters. The matter matters. If the matter is semiconductor, if the matter is a plant, if the matter is water, if the matter is a metal, if the matter is a liquid, if the matter is soil, if the matter is human body, biological, Bone, D vitamin. The sunlight is interacting with matter, it is interacting with the human body, we are getting the D vitamin. It is interacting with the soil, agriculture. It is interacting with the plant, photosynthesis. It is interacting with semiconductor, photoconductive effect. It is interacting with the water, rains. It is interacting with the metals, photoelectric effect. It is interacting with the liquid, analytical instrumentation, Beer-Lambert's law. This is how the light works. What is the beauty? What a beauty! Chiday Sharma, this is the beauty of light. Light is life. That's why human beings have taken 21st century, kitna saal ho gaya, after 2100s, now we are coming to solar energy. Everything is over भैया, coal is over, water is over, everything is over. Man पूरा dig कर दिया. Elon Musk तो Mars पर जा रहा है कुछ लाने के लिए. Elon Musk is going to the Mars to bring something. But we are not seeing the sun. The sun is having infinite source of energy. Infinite source of energy. Light is life. मजा आ रहा है. That's why in the recent exams like ISRO paper, GENCO paper, any electricity board papers you check, any electricity board, every electricity board. So that's why in the recent exams like NTPC, AP GENCO, Telangana State GENCO, SSC JE, AE, Rajasthan Vidyut Vitaran Nigam Limited, Uttar Pradesh Power Corporation, Karnataka Power Corporation Limited, Bhubaneswar Vidyut Nigam Limited, all these organizations, they will establish, they are converting into solar energy. So, in exam, even the ISRO paper also, in exam definitely light related questions you can expect. All are converting their percentage into solar energy. Thermal power plants, hydro power plants, they are focusing on the solar energy. LDR is not a UV sensitive device. In LDR we are having the materials. If you see these materials, cadmium sulfide and cadmium selenide, so they are sensitive for visible radiation. Lead sulfide and lead telluride, they are for IR radiation. LDR cannot sense, not for ultraviolet. For ultraviolet, you have to go for photoelectric effect. Ultraviolet can be sensed by photoelectric effect. Photoconductive effect is related to visible and IR radiation only. समझ में आपको? Uttarakhand Power Conduct is single paper for electrical and mechanical post. We don't have mechanical knowledge much as electrical student. What can do? Anand Bose, your doubt is solved. Alkali metals, Anand Bose, semiconductors, best detectors for visible and IR. Alkali metals, best detectors for UV radiation. Alkali metals means what? Sodium, potassium, magnesium, all these things. Questions solve karvavo NET type. Yeah, Chinoy Sharma, today I am discussing the concept. Okay, clear? Chalo, my dear students, you got LDR concept clear? Clear na LDR concept? LDR concept is clear? Chalo. So this is about LDR. Clear मेरे दोस्तों? Less theory, more NET questions है. शर्मा जी आपने लेट आ गया, मैंने पहले ही बोल दिया, मैंने आज क्या बोल रहा हूँ, अब मैंने आज क्या बोल रहा हूँ मैंने पहले ही बोल दिया, आप बोल रहे NET क्वेश्चंस, मैंने पहले बोल दिया आज क्या सेशन क्या है. एवरीडे वी आर डिस्कसिंग क्वेश्चंस, everyday we are discussing questions, everyday we are discussing questions. Today I am discussing the concepts of transducers. PhD, this is called photodiode. Photodiode is what? Photodiode is a reverse biased PN junction diode. Reverse biased PN junction diode. Okay. So when the diode is connected in the reverse bias, so this is a P type and this is a N type. Aranja boss, your doubt is solved. It is connected in the reverse bias. Today's microprocessor class, yes, today we are having microprocessor class at night, 9 p.m. I am going to discuss memory based questions with concepts. Okay, now today's microprocessor class is for especially for the electricity board papers. Okay, so photodiode, here if you check the photodiode now, we know for negative what happens, the majority charge carriers are holes here, the holes are attracted, majority charge carriers are electrons here, the electrons are attracted here. So when the holes are going here, here the minority charge carriers are, here the minority charge carriers are electrons, here the minority charge carriers are holes. So when you connect the negative bias voltage, what happens now? So these all holes will be attracted here and all electrons will be attracted here. So there is a minimum possibility of current. That's why in the reverse bias characteristics of the diode, if you see the diode characteristics, in the forward bias every diode conducts very well, but when it comes to the reverse bias it is very tough to get the conductivity. So this is a forward bias, but in the reverse bias there is no current, so there is, what happens now, there is a minimum leakage current. So minimum leakage current up to certain point, and there is a suddenly breakdown. To the breakdown the diode gets damaged. Sir, I don't have much knowledge of microprocessor, it will be beneficial for me to use. Yes, I will discuss from the basics, but within the restricted hours I have to complete. So try to understand the limits of the faculty also. Within the constrained hours, maybe I may be getting hardly 6 to 10 hours. So in 6 to 10 hours I will give you the overview. In 6 to 10 hours I will give you the overview. Clear? I will start from the very basics. So now if you check this particular point, what happens? As the holes are left, positive charge has been left, so here negative ions are created. And here at this side positive electrons are left, so positive charge is created. So there is already electric field, but there is no much conductivity because of the depletion region width has been increased here. Depletion region width is more. So whenever the light falls now, whenever the light falls now, what happens? The photons are hitting. As per the photoconductive effect, what is happening? The photons are hitting the semiconductor layer. The electrons which are at the ground level, they are going to come to the upstairs. So because of that, what happens? Electron hole pair is going to be created. The electron hole pair is going to be created here. Like this. Okay na? So photons are hitting, EHPs are prepared. The photons are hitting. As the number of photons is increasing, number of electron hole pair is also increasing. So that's for the photodiodes quantum efficiency. What we call this as quantum efficiency of the photodiode. Quantum efficiency of the photodiode is defined as how many number of EHPs are generated. EHP is generated by how many number of photons incident. So if you take like it is a percentage, it is going to become into 100. So now what happens? This particular electrons are repelled, then slowly the electrons are moving like this. So this is the direction of electrons and this is the direction of photocurrent. So what is happening? The optical power is hitting. We are getting the current. So output is the photocurrent generated and input is the optical power incident. So this is also one important parameter. Photocurrent generated per optical power incident. So this is what we call as responsivity of the photodiode. What we call it as? Responsivity of photodiode. Okay na? So this is what we call as responsivity of photodiode. Is it clear, my dear students? So responsivity of photodiode is also important. So the units are what? Ampere per watt. So you should have idea of all this terminology. Clear, my dear students? Clear na? So today we have discussed the list of non-electrical measurements. In the upcoming classes, we will discuss the remaining measurements. See, for power plants, if you are preparing for power plant exams, power plant related jobs, you must focus on these parameters: temperature measurement, pressure measurement, flow measurement, light measurement. So these are the major topics. For every electrical engineer should have some temperature measuring instrument, some pressure measuring instrument, flow measuring instruments, light measuring instruments. Yeah, my dear students, one thing I want to tell you. Why minority carriers are more noisy? What is noisy? I don't understand. What is the question clearly? Why minority carriers are more noisy? What is noisy here? I don't understand. I don't understand your word noisy. Yes, Sharma, today no questions. Yes, Sharma, today no questions, only theory. Today I have given you only the concepts of, no, I don't understand your question clearly. Noisy means what? See, minority charge carriers and majority charge carriers both are affected by temperature. The noise effect is there because of temperature. Okay, na? The noise effect is there because of temperature. So if you are preparing for electricity board papers, so you must focus on temperature measuring instruments. Under the temperature measuring instruments, you used to have these words RTD, thermistor and thermocouple. RTD, thermistor, thermocouple. Next, under the pressure you are having piezoelectric crystal. Under the flow you are having flow transducers, flow meters. Under the light, optical transducers. So those who are preparing for exams like power plant related jobs, please focus on these measurements. Okay, my dear students? Sir, you also take measurement class in GA app. I will update you. Sharmaji, I think you are disappointed today. I am taking only theory. Huh? Sharmaji, are you disappointed today? I am taking only theory. Daily I am taking problems, man. Today only I have taken this session. Reverse bias current is mainly dominated by temperature. That's why I am asking. Yes, yes. Every 10 degrees Celsius temperature increase, the reverse current of diode gets doubled. Yes. Yes. Why? Because reverse bias current is going to be effect on the temperature. Yes. That's what noisy word I didn't understand. See, whenever you are increasing the temperature, definitely the temperature acts like energy. The energy creates certain thermal agitation. That because of the thermal agitations, the collisions will take place. Because of the collisions, automatically the minority current gets changed. Minority current gets changed. If you are keeping the voltage as constant and if you are increasing the temperature, then definitely it can affect the minority current. So that's what we have seen in the diode current equation. ID is equal to I naught into e power something by Tk minus 1. There is a temperature plays a major role. Okay, my dear students, we'll meet tomorrow. We'll meet tomorrow with a new topic. Okay. I have given just a glimpse of all transducers, basic transducers glimpse I have given. Thank you. Have a nice day. I posted already in the link. Already posted in Telegram. Yes. Thank you. Bye bye. Have a nice day.